Hello everyone. In this tutorial, let's see how we can convert hexadecimal number to binary number. So let's see how we can convert A2 into binary B7, C000, and we can take one or two more examples. So before we start, let's have a table that can help us convert any hexadecimal number to binary number. So let's write it here. So we have the decimal, and then here we have the hex, and then in the last column, let's have the binary equivalent. So in binary, if we have 1, 1, 1, 1, so we know we start 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. If we do the math, so we get from this guy here, we get 8, 4 from this number, 2, and 1. So let's start. So in decimal, if we have 0, in hex, it's 0. In order to get binary, so it stays 0, 0, 0, 0, 0. How about 1 in decimal? It's still 1 in hex. In order to get 1, so we need to have this bit 1 and the rest are zeros. So we have 0, 0, 0, 1 in binary. 2 in decimal is 2 in hex. In order to get 2, we need this bit to be 1. So we have 0, 0, 1, 0. 3 in hex is a 3. In order to get 3, we need to add 2 plus 1. So we need those two bits to be 1s. So 3 in binary is 0, 0, 1, 1. 4 in decimal is 4 in hex. In order to get 4, we need this bit here to be 1. So that's 0, 1, 0, 0. 5 in decimal is 5 in binary. In order to get 5, we need to add 4 plus 1. So that means these two bits need to be 1 and these zeros. So it is 0, 1, 0, 1. 6 in decimal is 6 in hex. In order to get 6, we need to add 4 plus 2. So that means those two bits need to be 1. So 0, 1, 1, 0. 7 in decimal is 7 in hex. In order to get 7, we need to add 4 plus 2 plus 1. So that means these three bits need to be 1. So that's 0, 1, 1, 1. 8 in decimal is 8 in binary. In order to get 8, we need to make this bit 1 and the rest zeros. So 8 in binary is 1, 0, 0, 0. 9 in decimal is 9 in binary. Sorry, 9 in hex. And then in binary, to make 9, we need these two bits to be 1. 8 plus 1 is 9. So that means 1, 0, 0, 1. 10 in decimal is letter A in hexadecimal. In order to get 10 in binary, we need to make 8 plus 2. So these two bits need to be 1 and these two are zeros. So 1, 0, 1, 0 in binary. 11 in decimal is B in hexadecimal. In order to get 11, so we need to do 8 plus 2 is 10 plus 1 is 11. So that's 1, 0, 1, 1. 12 in decimal is C in hexadecimal. In order to get 12, we can add 8 plus 4. So that's 1, 1, 0, 0. 13 is D. In order to get 13, we can do 8 plus 4, 12, plus 1, 13. So these three bits need to be 1. 1, 0, 1. 14 in decimal is E in hexadecimal. So that means in binary it's 1, 1, 1, 0. Lastly, 15 in decimal is letter F in hexadecimal. In order to get 15, you need to make all bits are 1. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So that is 1, 1, 1, 1. So now with this, we can convert any hexadecimal number to binary. So let's take A2. And in most book literature, $sign stands for hexadecimal. So when you see a $sign, that means it's hexadecimal. So in binary, percentage sign means binary. So what is letter A? Letter A from this table is 1010, so that's 1010. And number 2 is 0010, so 0010. So this one is the binary equivalent of A2. This stands for A, and this is 2. Let's take the second example. Let's convert B7 to binary. Same idea. B is 1011, and number 7 is 0111. So this is the binary equivalent. And those are, when you see like two things, that's like 1 byte, because 1 byte is 8 bits. And this is also 1 byte. How about if we have 2 bytes? C0 is 1 byte and 00 is a second byte. Also, we follow the same rule. So what is C in binary is 1100, and then 0 is 4 zeros. And then we have this 0 here, 0000, and then we have 0000. So if we count this, that's 16 bits. This is 1 byte, and this is 1 byte. So let's take C00A, for example. So the binary equivalent to this one, C is 1100, 0 is 4 zeros, and we have the other 0 is 4 zeros, and then we have letter A, and hexadecimal is 1010. So this is also 2 bytes. We have 1 byte here, which is 8 bits, and then we have 1 byte here. So knowing this table, we can easily convert any hexadecimal to its binary equivalent. I hope this video was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.